Hi, my name is Dave Triano and I'm president of Shadow Composites, and welcome to the first in our series of advanced composite construction techniques videos. Today this is going to be a basic video that covers all different kinds of materials, all their properties, and completely how to use them in wrapping your own composite body tubes for high power rocket applications. So a little bit about myself. I've got over 20 years experience in advanced composite industry, from home-built aircraft to commercial aircraft companies, and also other marine applications and sporting applications. So hopefully with this series of videos we can get that 20 years of experience condensed down to you in a more effective manner, so that you don't have to go traipsing all over the planet, spending money, spending your time, and ended up with a mess on your hands instead of the good composite aerospace structure that you really want. So with that said, let's start in, and we'll just do a little discussion here about different types of fabrics that you'll use in composite construction. The big three fabric types that you'll see are fiberglass, of course, also known as e-glass, carbon fiber, and Kevlar. A lot of you are familiar with Kevlar for use in recovery systems for straps and things, but we're going to use it as Kevlar cloth. Fiberglass cloth comes in a wide variety of weights, different types of weaves, and different types of finishes. What I'd like for you to do is look at the vendor list that I'll supply with the video, and look in there for a good standard fiberglass or e-glass in around a 5 to 8 ounce weight per yard. That's the most workable weight for high power rocket applications. Some guys use much lighter weights, they call it a sanding veil. I don't like to even bother with the lighter weights. They don't provide as much strength, and they really are more trouble than they're worth. So stick with a 5 to 8 ounce in the glass cloth. When it comes to different type of weaves, let me just talk using this little illustration here. There's basically two types that you're going to encounter when you're looking in these vendor supplier catalogs, and that's plain weave, which is shown here, which is just what it sounds like. It's a weave that's interwoven every course of the weave at 90 degrees to each other, and that's your standard construction. If it's not called out in the catalog what it is, it's probably plain weave. The other weave that you'll see is crow's foot weave, which, as you can see, it skips over a course in one direction of the weaving. What that does is enables the cloth to be more flexible, and you use that in compound curvature applications like nose cones and things like that. So you can also use the crow's foot when you're wrapping body tubes. Really it comes down to whatever you can get a good cost on. So that's your basic weave patterns. There are other types of weaves. There's all kinds of different types of weaves, but these are really the only ones that you're going to encounter, and they're the easiest to use. The second type of cloth that we're going to be working with today and that you'll encounter is carbon fiber. Right off the bat you see it's black in color. It is carbon, and it's vastly more expensive than your fiberglass cloths. But what you get with carbon fiber is a tremendous increase in stiffness and strength. That also comes in the two different kinds of weaves. Again, stick with a 5 to 8 ounce product for most of your wrapping needs. The third type is Kevlar or aramid, and this is very, very tough stuff. It's different from the glass and the carbon in that the Kevlar, once it's in its matrix, is very impact resistant. It's also fairly light for its weight. So we'll talk more about these different properties that all of these cloths have as I actually laminate them. But these are what you're going to run into in the supplier catalogs that you'll find. Kevlar falls about right in between fiberglass and carbon price-wise, and there are some very specific requirements for working with it as far as being able to cut it and stuff, and we'll go through that in a little bit. The weights per yard that I'm talking about of 5 to 8, what you'll see is cloths ranging from 0.3 ounce all the way up into the 28 ounce realm. And the 28 ounce and all those higher realms are basically for boat construction and reinforcement, and really anything above 12 ounces used in boat construction. It's made to soak up a lot of resin and get a good thick build layer onto the boat mold quickly. We want to create an aerospace structure, so what we're aiming for is lightweight, high strength, and keep the cost in reason. So that's why we're going to stick with the 5 to 8 ounce. These are also the most common types of weights of fabric out there that you'll find. So look for those and then shop them around as far as price is concerned. When it comes to cutting these different types of fabric, let's start with fiberglass. I like to use a nice rubberized cutting board like this. You can get them in any types of size, but it's got a nice grid pattern on it that you can go to. When working with fiberglass, all you have to do is simply roll out the fiberglass, and I like to use my favorite tool for this. It's just a single edge razor blade. You use your straight edge and use a single edge razor blade to trim it. When you're working with any of these cloth types, be sure when it comes from your vendor, it may have some warp in the actual thread direction. Be sure to just kind of shift all those threads and get them all square and lining up with each other real well. That way when you go to cut it, you won't have a lot of loose fibers. The straight edge razor blade also works very well for cutting carbon cloth. It's a little tougher, so you have to bear down a little bit more, but it'll zip right through it. Another thing that you might want to consider is the use of a razor knife pizza cutter type affair like this. They roll on the surface, and actually they work very well for cutting carbon because there's no pulling involved as with the straight edge razor blade. It just rolls right through the material. So these are real good to use too. When you're cutting Kevlar, however, the reason why they make bulletproof vests out of it, and the reason why they make cut-proof gloves for butchers out of it, is because it's just that, cut-proof. It's very, very difficult to cut. If you're going to be working with any quantity of Kevlar, I'd suggest getting a pair of Kevlar cutting shears like these. They have a special finish on them, and you can get them as inexpensively as $19 from some manufacturers, but you really need this to cut the Kevlar. Any other cutting method will just snag and pull on the Kevlar cloth itself, and you won't be able to cut it. So that's one of the special needs for dealing with Kevlar. When you're talking about creating a composite structure with a tube, it really is that. Creating a composite structure is much more than just slopping on a bunch of epoxy over glass cloth until it becomes clear, and then you're left with a very heavy mess on your hands. The aim of creating a composite structure is to wrap the tube with a ratio of cloth to resin of roughly 50-50. That means most of the people out there are using way too much resin in their layups. When you, like some of the guys that I've seen out there, they will just take a plain paper tube and they'll paint it with resin. You're doing absolutely nothing except adding weight to your rocket. The way composite structures work is that these cloths of the different types are impregnated with a matrix of that resin. The resin works its way through all of those fibers, and then when they're in conjunction like that and the resin cures, then you've got a structure. Without the cloth, you have no structure. Resin on its own, I'm sure you've taken some of the drops after resin is cured, and you can snap them real easily. It's very, very brittle by nature, and it's very heavy by nature. So you don't want more resin in your layup than you need. And really that's a 50-50 ratio for most cloth types. Another misconception that I see about guys creating composite structures is they'll take a tube like this, and I even heard of one fella taking pantyhose and then impregnating that with epoxy and thinking that he had a composite structure. These materials, the glass, the carbon, the Kevlar, are all meant to accept resin and have it intermingle with their fibers. When you use nylon, like in pantyhose, nylon doesn't stick to much of anything, and all you've got is a material inside of that epoxy that will eventually shake loose and fail. So the information that I'm going to give you about creating composite structures is very critical. Again, it's taken me 20 years to figure all of this stuff out, and that's through tons of reading, tons of doing and failing, and tons of talking with old hats in the industry that really know what they're doing. So follow my lead and you'll have a good structure. A little word about safety. Whenever you're cutting any of these materials, at least wear a dust mask. I like to use these little dust masks. They're disposable, and they've got a little respirator end on them as well. These are good while you're cutting the materials. Things like carbon fiber, they're very small fibers when they get airborne when they're cut. If that gets into your body, you're going to be paying for it later on in life. It really is not a pretty situation to see some of the people that have had problems with carbon. Kevlar is very similar. Glass is mostly irritating, but all of this stuff, you just don't want it in your body, not for the sake of a hobby. So wear a small mask like this when you're cutting it. When you work with the resins, with epoxy resins, polyester resins, whatever resins you're working with, please wear a dual cartridge respirator when you're dealing with these resins. These resins, the ingredients in them have a cumulative effect in your body. And as you're working with these resins, that toxicity level in your body builds up. And I've seen some old guys that really aren't very long for this earth because they never wore any of this protection. So again, it's just a hobby. Use this stuff. When we're talking about resins, there's three basic types. There's polyester resin, which you know for its use in boats and recreational products. There's a product called vinyl ester resin, and then there's epoxies. The only one that's really suitable for our applications in the high-power rocket community is epoxies. And a word about the epoxies that you'll see in hobby shops. What that stuff is, it's not really a tailored professional level epoxy. You'll find the same kind of stuff under little squeeze cans in Kmart and stuff as well. That stuff does not give you the engineered performance that you're going to get with a professional epoxy, and you won't get what you want out of it. My favorite brand of epoxy that I use is a product called Aero Epoxy. I don't get any kickbacks from them. It's just a product that I've found works very well and reliably over the years. What you'll get is a portion of resin and a portion of hardener. These have to be mixed in very critical proportions. The proportions of these things are, again, the company has engineered this resin to perform and give you certain characteristics. If you vary the proportions of hardener to resin, you're going to end up with either a laminate that doesn't cure at all, or one that comes up with a very aggressive cure. But either of those extremes, you're not going to get the mechanical performance that the manufacturer is calling out. So I like to use this Aero Epoxy stuff. There's about 5 brands out there that are really good. West System is another very good brand. Hexcel makes some very good resins. It really doesn't matter which one you use, as long as it's a good professional resin. The difference between these guys that make these products and the little hobby shop stuff you see is that these guys are the actual manufacturers of the product. They create the chemistry that goes into the product from its base constituents. The other guys, that you'll see out there are basically epoxy blenders. They buy the base constituent mixes from the big guys and then they mix it themselves, and not always in a very effective manner. So stick with the professionals. This stuff will get you what you need. Now, I mentioned that the mix ratio on these epoxies is very critical. Let me show you a couple ways to get that critical ratio. In our shop I use a few of these. This is a digital scale. They work very, very well. You can measure down to the gram and get an accurate proportion. Most, like the air epoxy, the proportion on it is 100 parts of resin to 27 parts of hardener. And so it's very easy to get with a digital scale. For those guys that don't want to invest in a digital scale, you can get an accurate volume measurement pretty easily. And that's by using, just use your epoxy cups and get a small cup for your hardener and a larger cup for your resin. Take some rice, just common household rice that's in a container, and into your small cup pour about 1/3 of the final amount of resin that you expect to use. When you've got that in there, make a mark on the inside of your small cup. Then pour it into the big cup. Add more rice to the small cup until it comes up to that level. Add it to the big cup. And do it again. What I'm doing here is a 3-to-1 mix ratio. That's fairly common among most of the epoxy manufacturers out there. But now that I've got 3 parts from the small cup into the large cup, I make a mark on the large cup, and now I've got a mix. 3 parts of resin to 1 part of hardener. And this is generally accurate enough to get good performance out of any of the epoxies. You may have to vary this on some of the other epoxies. Some are 4-to-1 mix, but it's all a matter of proportion. So it's a very easy way to get an accurate measurement. Do not measure the stuff by eye. It won't work, I'll guarantee it. I talked about the different kind of resins and mentioned polyester resin, which is used in boat manufacture. There are some manufacturers in the rocket community out there manufacturing nose cones made with polyester resin. I don't think this is necessarily a good thing to do. Polyester resin has some unusual characteristics about it in that it is not heat tolerant whatsoever. Any heat over 110 degrees is going to start to plasticize polyester resin. And so if your rocket is sitting out there on a hot day in the sun, it's going to get up to 110 degrees if it's painted anything except for white. So keep an eye, watch out for that polyester resin. It's very distinctive when you, to recognize it when you get that part, you can smell it. It gives off a very distinct styrene odor. So watch out for that kind of stuff. And look, if you're going to buy some resin in a home store or something, they do sell resin. I believe it's under the Evercoat name. You can get epoxy resin, but if you look at buying resin in those type of home stores, check the label, make sure it's not a polyester based resin. You will only get the higher performance with epoxy based products. The vinyl ester resins that I mentioned are a slightly higher temperature, very similar to phenolic in applications, and a lot of rocket people use phenolic airframe tubes in their rockets. All that is basically is a paper tube that's impregnated with this phenolic resin. The vinyl ester resins are somewhat similar to that, but they mix very much like polyesters. They're a little bit more of a strange animal in that most people don't have very much experience with vinyl esters. So just stick with epoxies and you'll be in good shape. When you're talking about heat curing on resins, a lot of guys will take hobby epoxies and to get them to kick off faster, they'll heat them up, they'll put them in an oven, and that can make a very, very aggressive reaction in which the hardener just really goes at the resin. And I've actually seen cups that will catch on fire of resins used that way. If you use the resins that I've talked about, the System 3 or the Aero Epoxy or the Hexel, in the correct proportions, they'll give you an hour's working time, and that working time, you don't have to hurry it up. You don't have to worry about doing any of that heating up. You also don't have to spread them out on thin sheets or anything like that to deal with them. If you follow the proportions and your ambient temperature is correct, you'll be in good shape. So follow all the recommendations when you go to use those type of epoxies. There is a type of cure for epoxy resins, and it's known as a post-cure. Most guys have a little bit of knowledge about what a post-cure is, in that they know they want to take that cured part and they want to heat it up after it's cured in order to get a higher temperature resistance or a higher strength. Those little items are true. What you have to watch, though, is that each specific resin has a specific post-cure schedule that it must go on. You get those by talking with the technical staffs at the epoxy manufacturers. For instance, if I have an epoxy fiberglass layup, normally in its cured state, its temperature resistance is going to be up around 125 degrees before it starts to soften. I want to raise that up. I call the epoxy manufacturer and they give me a post-cure schedule. This schedule is something like this. The laminate is raised 10 degrees in temperature, held there for an hour, another 10 degrees in temperature, held there for an hour, and so on and so forth until you reach the desired temperature resistance. Then it's held there for about 4 or 5 hours, and then that cycle of ramping it down is at 10 degrees every hour also. So the whole cycle takes about 16 or more hours to go through for a good post-cure cycle. Also for that, you have to have a composite oven with a good thermostat control on it. That's a good weekend project for guys at home. You can make one simply out of plywood with foil-faced insulation on the inside and infrared heat lamps to provide a heat source. So you can do post-cures, just realize that they're very specific to the different kinds of resins that you use, and you have to call their technical staffs and get that post-cure cycle. Some resins, like the System 3, give different hardeners as choices with the resin so that you can vary that cure time of the epoxy. If you want to have the epoxy set up in 20 minutes, use a 20-minute hardener. That's all very good to do too. But like I said, don't try and increase the heat to kick off your resin. The mechanical properties of the laminate will suffer, and you won't be doing anything except running the risk of creating a big mess. So when you're creating things like fillets, and here I've got a couple of the Shadow Composites Raven rockets, the little fillet areas that attach the fins to the airframe. There's a couple different ways of going about that. The fillet that you want to create, if you're creating a epoxy structure on your airframe tube, you want to use a fillet material that's made out of epoxy as well. When you go to rough up the structure of the glass surface after you've completed that, that'll provide a good mechanical tooth to it, so the fillet material will grab onto it. But you also want somewhat of a chemical bond between your fillet material and your airframe. So there's a couple different ways you can go about that. There's a product out on the market called Superfill, made by Polyfiber. Again, no endorsements from these guys. This stuff is just really great to work with. Very, very light for creating your fillets, and it's epoxy based. Most of your fillers out there, like Bondo and things like that, are polyester based, and polyester will not stick well to epoxy. Eventually down the road, those two substances will separate themselves from each other. So these type of materials are real good. You can get them in any of the vendor catalogs like Aircraft Spruce and Specialty or other places like that. But I like to use an epoxy-based filler on an epoxy airframe. When you go to do that, you can also essentially create your own filler. If we could just zoom in on these guys right here. What I've got here are some different materials that my company, Shadow Composites, sells. These are amendments that you mix in with the epoxy to thicken it and give it some mechanical structure. Because remember, epoxy in its base state has no stiffness to it. You have to add some structural element to it. So we sell a number of these amendments in milled glass fiber, which is very small ground fiberglass, creates a good strong fillet. Cotton, it's called flox fiber. This actually thickens really well and gives the same kind of effect. And if you really want to get very, very strong fillets, then you go to things like Kevlar pulp or chopped carbon fibers. And these are a little more difficult to work with in that you have to be very clean in your application of them. You don't want to have to be sanding these afterwards because they're very, very tough. But you mix them in a 16:1 ratio with the epoxy just until you get your desired consistency, and then run your fillets with those. It gives very, very strong structural fillets. So that's about it for the introduction of all the materials that we're going to be using today. And again, the biggest point that I want to get across is we're constructing composite structures here. We're not just slapping on some resin onto some fiberglass. Remember, excess resin means extra weight. It doesn't mean extra strength. So, with that in mind, let's move on to starting a glass tube wrap. What I've got here is a 54 millimeter tube, and these tubes that I'll be using as a base, excuse me, are just basic paper tubes for many of the manufacturers like Rocket R&D or Lock Precision or Vaughan Brothers if you're on the West Coast. Inexpensive paper-based tubes. I haven't done any reinforcing on the inside of them or anything. It's not necessary with this, with the way we're going to be doing it today. You'll see I've got these set up on a structure here that enables me to wind the cloth on very easily. It's just a couple of triangular supports, and then you can make these out of plywood in your own workshop and run a broom handle right through the middle, and that'll give you something to wind the cloth onto the tube with. Very easy to work with, and it helps a ton. So get yourself a structure set up like that on a table. As you can see with this tube, if we can zoom in on one end here, we've got the paper tube, and then I've taken a tube coupler and covered that with wax paper. You can use release film or anything you want, but what I'm doing is covering that coupler so it won't be ruined during the lamination process. I've just attached it onto my little fixture here with a little masking tape just to keep it from moving. But I've done that to both ends, and they're just inserted friction fit into the tube. A good friction fit will keep it from going anywhere. Now also, we want these coupler ends on the end of the tube so we have a little bit of runoff off the end. You don't want to just try to laminate just this tube. The ends of the cloth will ramp up at the end if you try to do that. And I like to use the whole tube and get the whole tube's length in my laminated structure without having to trim it back because I've got ramps off the end of it. So I provide a little runoff with these couplers, and that seems to work very well. So once you've prepared your tube like this, we're all ready to go. You want to cut your cloth, and this is all pre-cut, of course, but the product I've got here is a fiberglass known as S-glass. Now you recall when I was talking about the fiberglass product in the beginning, that standard fiberglass is known as an E-glass. This is called S-glass, and that's because the formulation of the glass itself is different in that it's going to give a higher strength characteristic than standard glass. It's a little bit of a price jump up to use S-glass, but this stuff handles the same as E-glass, and it'll give a good demo for using standard fiberglass. Now what I've done is I've got good clean edges trimmed on my piece of fiberglass. I've got about a 1/2 inch overlap on either side of the tube in length. I've figured this out so that this one will make 2 wraps of this 54 millimeter tube all the way around and then meeting at the very end. So all the edges are nice and clean and square, not a lot of ragged edges of fiberglass hanging out everywhere. If you do have an occasional one, it's not a problem. Just try and keep everything as clean and neat as you can. So we prepare our glass that way, and now we'll go and measure out some resin. I'm going to measure mine out with the digital scale. For the sake of time, it just makes it a heck of a lot quicker. And we'll run through all different kinds of tubes by using this technique today. So we've got our resin and a resin cup. What I do is put the resin cup on the scale, and then the scale is just zeroed out. Be sure when you're working with epoxies to also wear some safety gloves. Little latex gloves, they're very inexpensive, and you can pick them up at your local hardware store. But wear these guys. What you get if you don't is over the years your body will, as those toxic constituents of the resin build up in your body, you'll develop a epoxy allergy, and it'll manifest itself by a lot of bumps all over your skin and breathing problems and all kinds of things like that. So keep the stuff off of your skin. I've seen guys out there that say, well, I just like to get down and get dirty with it with my hands, and then I just dunk my arms in acetone to clean it off. Well, that's very manly and all, but the problem is that the acetone, it puts the epoxy into a more soluble nature, and then the acetone is absorbed directly into your bloodstream. So that's just like mainline right to your heart of all of these chemicals, and that's not good. So wear the protection. So I've got my scale zeroed out, and I'll put my cup on there, and I'm just going to measure out about 100 grams of resin. And I'm doing that because it's an easy proportion to measure, again, when I get my hardener going. And that's going to be more than enough to laminate this 2.5 inch tube, or 54 millimeter tube. When you're working with your epoxies, keep all your cans and everything very clean. Wipe any excess that gets on the lip of the can off, and keep everything nice and clean when you're working with it. Again, so it won't get on your hands or anything, and also so the resin doesn't get contaminated by anything from the outside. You don't want anything nasty getting in there and screwing up your resin cure. So there's our 100 grams of resin. We'll take that off of the scale and zero out the scale again with the smaller cup. And this is the 100 to 27 ratio. 100 parts of hardener to 27 parts of, 100 parts of resin to 27 parts of hardener. And so I'm just getting right to 27 grams. A little bit more. There we go. Okay. Same thing applies with the hardener as far as keeping it clean. It's good to have a little roll of paper towels handy while you're doing all this stuff. If you get any drips, you can clean it up real easy. To mix the resin now that we've got it proportioned, you just add the hardener to the resin. Be sure to scrape out the any hardener in there so you get an accurate proportion. You don't want a gram of hardener left in your cup. And then mix it very well. Any parts of hardener that aren't mixed in with resin are essentially going to leave a soft spot of resin. So make sure the hardener is very well incorporated with the resin. You can whip it up real good, scrape all the sides of the cup, and get it going. I'm just using a standard plastic beer cup for this. It's nice to use just a clean paper cup so nothing gets into it. If the resin does start to kick off and get hot, it's going to probably melt this plastic cup, but I've got pretty good confidence in the resin and how I'm using it, so I know I'll beat the resin to the punch as far as the lamination is concerned. But try and get some paper cups, that works well. These work good if you do have that confidence involved in what you're doing. But I use tongue depressors, disposable, and real cheap. You can get them boxes of 1,000 of them for 10 bucks to mix all this stuff, and that works very well. So now we've got our resin mixed, we've got our cloth ready, and we're going to start by just using a little inexpensive resin brush to apply some resin to the tube. And I'm just going to basically paint half of this tube around its circumference just to adhere the cloth to it. Now remember, the whole point of doing this is to keep your resin and your cloth ratio as close to 50% as possible. The way you can do that with glass is to apply resin until it just goes clear in appearance, and you don't want a complete glossy sheen over the whole thing, but we'll see that as we get going in this process. So I'll just paint the resin on with the brush. A lot of guys will use a somewhat different technique to work the resin into their cloth. I use these little bristle brushes just because I'm used to it, and it's a very inexpensive and easy way to go. A lot of guys will use little squeegees actually to try and get the resin out of the cloth, or move the resin around on the cloth. That's fine too. Okay, so we're just applying resin to half of the tube, just enough to get it glossy. And now I've got my glass cloth, and I'm just going to tack it to the tube, trying to go as straight line as possible. It helps a lot of the time if you take and run a marker line the length of the tube. So now that's all tacked down. Now there's a little technique here, if we can zoom in on this. When you've got the edge down like this, you don't want to go brushing like crazy over it, or you'll pull up the loose fibers that are on the end of the glass cloth. So you take the brush and just roll it right over the edge like that. Rolling, and it's not picking up any of the fibers. And it's saturating that cloth and getting it well impregnated and filled with the resin. You want to get this edge stuck down real well so that when you come back around on your second wrap of the tube, you don't have it sticking up at all. That'll cause a number of air bubbles to get into the laminate. And air in a laminate causes the laminate to lose strength in that area. So you want to try and eliminate as many air bubbles as possible. So just rolling right along the length of the tube, getting it all stuck down. And now that I've got that edge stuck down, I can really go to it, and I can do some brushing with resin and get the rest of this cloth saturated. Again, you just want to go until the cloth becomes transparent. You don't want to gob on the resin so that it's a real glossy on the surface, but just work it along its length. If you get towards those edges, use that rolling technique again so you don't pull up any fibers. And then just use gravity basically to work your way around the tube. You don't have to do any pulling down of the cloth or anything to tighten it. Gravity and your brush work will keep it running nice and snug to the tube. So just work it all the way around. Now this layup that I'm doing right now, I'm just going to leave it with the as just a plain glass wrap. The other tubes that I'm going to be showing you in carbon and Kevlar, we're going to be using a different technique called heat tape winding on those. But this one, this way is the way a lot of guys out there like to work on their rockets. Not using any different processes, and this is a good way to start out and get some practice as far as using all the materials. Don't go and try this on your big 8-inch diameter project as your first attempt at glassing. Use some paper towel rolls and some inexpensive fiberglass and resin, and get a hang of the process before you go diving into something like that. If you do it on your first go, you'll probably ruin your big 8-inch tube. Now if we could just zoom in on an area here. Down here is an area that I have glassed already, and you see the resin has saturated the cloth. It's clear in appearance, you can see right through it. Up here is cloth that hasn't been saturated yet. Obviously it's kind of glossy, metallic, pearly white. As I add the resin, you can see it saturates the cloth, and now you can see the tube underneath. So that's the appearance you're looking for as you work your way around. There's a lot of discussion as to how many wraps of cloth you can do around a tube. When you're doing it like this, with just a dry wrap, I call it, just wrapping it around the tube naturally, and you're not going to follow it up with the heat tape winding or any vacuum bagging, try and keep it to two wraps. Now if you think you need more strength than that, go to a different material. Use a stronger material like carbon fiber or Kevlar. But it's not in your best interest to add more than a couple wraps of cloth, because those extra wraps, you're just increasing the probability that air is going to get into the laminate and decrease its strength. So it's a good rule of thumb. Figure on wrapping your tube twice, and then look at the material specifications in the vendor catalog as far as tensile strength and all of those things to see what material fits the amount of strength that you want to get onto your airframe. Now in this tube, we're also just wrapping this glass cloth as a reinforcement onto the base paper tube. You can do this also with phenolic tubes. You can use just one wrap of glass on a phenolic tube. If you use the 5 to 8 ounce glass range, that will provide you with a very strong structure. What I'm going to be showing you on the Kevlar tube as we do it is a situation where I take that paper-based tube and it has mold release applied to it. So we will be wrapping that tube with Kevlar, and then the magic of these paper tubes is, other than the fact that they're cheap, is that you can then go back and dissolve out that paper tube from inside of your finished laminate and have a very nice composite only structure without the paper tube. So we'll be doing that in the Kevlar wrap video. But as you can see, I'm just reaching about 3/4 of a wrap to go here. Continuing to work the resin into the cloth until it loses its milky or white appearance and becomes clear. Allowing gravity to really pull that cloth around the tube. And I'm not coming up with any air bubbles or anything strange like that. No wrinkles. It's just going on naturally and going on well. When you start pulling on it and torquing on it, that's when you're going to start to get things askew and you might get some wrinkles. So just let the resin and the cloth and your little tube winding fixture do the work for you. It works out a heck of a lot better. As you can see, I'm working outside here. If you do this kind of work inside, which is actually ideal, you should be doing this inside so you don't get a fly in your laminate or things like that. Please use a real good cross-through ventilation in your room. And don't do this inside the house where the rest of your family is. You may have the respirator on, but if the rest of your family is breathing this stuff going through your home heating system, you know, you don't want to do that. So be sure that where you're working has a good ventilation going through it. Now I'm reaching the end of the cloth, and I'm just wrapping like this. If we could zoom in on this just a little bit, just wrapping off the end of the cloth. I'm wrapping like this, and I'm able to do this instead of the roll technique because the factory edge of the cloth is what I'm ending up with. So try and do that at the end of your cloth. Wrap. And there we've got a finished glass tube. Now, as I said, we're going to do heat tape winding on the next ones, but if this is just that plain wrap technique, and that's it. You see, it took me a matter of 10 or 15 minutes just to lay this on here and go. Again, you can see the texture of the cloth in here. It's got a nice semi-matte appearance. It's not thoroughly glossy, and there's no runs or dripping resin anywhere. It kept it all nice and clean. So if that's where you want to stop with this process, there you go. So now we'll just take this guy off the fixture and move on to the next one. The next tube that we're going to be wrapping is going to use carbon fiber, and we're going to use the heat tape winding technique on that. So just take this right off. And set it aside. Okay, this tube is set up for the graphite that we're going to roll on here, and we're going to incorporate a couple new ideas with this wrapping technique. So let's set this up in the fixture. And we'll get to it. Now, when working with graphite, again, I gave you the recommendations about you know, protecting your lungs and everything while you cut it. So we'll assume that you've done that and that you've gotten a good piece of graphite that'll give you, like on this one, 2 wraps around the tube. The graphite that I'll be using for this wrap will be a 5-ounce graphite, and very, very strong stuff. A lot of people shy away from using graphite because they hear it's brittle. Well, the thing about graphite is, yes, the nature of the material is that it's brittle, but that's only in relation to other materials and how they're used. Graphite is an exceptionally strong material when used properly, and it's exceptionally lightweight when used properly. So we're going to show you how to do a 2-wrap on a paper tube. Again, this is set up identically to the last tube that I dealt with, and I'll talk throughout the layup about carbon and its specific strong points. So first thing, let's mix up some more resin. We've got the scale all ready to go. And we'll zero out our scale and measure out our hardener. Again, I'm going with about 100 grams for this. That will provide more than enough for our purposes here in wrapping this 54 millimeter tube. Just put that down there. And then 27 grams of hardener. There we go. And we'll mix this up well again. Sure to get all that hardener out of the cup. Now, a key when working with carbon and Kevlar materials that you have to understand, they are not going to wick up that resin and saturate as easily as the fiberglass is. With carbon and with Kevlar, you almost have to force the resin into the weave of the cloth by some means to really have the most effective laminate. So what we're going to do is this heat tape winding technique. Most of the laminate proceeds just like the last laminate that we did, except I'm going to be using a little more epoxy. I'm going to lay the epoxy on the whole tube this time. I'm not laying it on so it drips. I'm just giving a good gloss to the tube again so I get good adhesion to the tube. But we are going to be using more epoxy during the lamination process itself, and that's all in the interest of getting that epoxy into the fiber matrix of the cloth. If the epoxy isn't in the fiber matrix of the cloth, you have nothing. If it's just plain epoxy on the surface, or if it's just plain cloth, you have no strength whatsoever. So it's got to be the combination of the two. Okay, so I've got the whole tube coated with resin now, and I'll grab my carbon. This is pre-cut again to give exactly 2 wraps right around this tube. You'll notice right off the bat that the cloth is a little bit stiffer to deal with. It's because the carbon fibers themselves are stiffer. So, same as last time. We kind of tack this onto the tube using our fingertips. And we're trying to get this on the tube nice and straight. And we can zoom in again on the brush area. This is the rolling motion that we used in the glass cloth. Use this whenever you approach the edge of whatever cloth you're dealing with so that you can get that edge to stick down without separating too many of the fibers from the layout. Okay, now we've got that stuck down on the edge, and we're going to come back and start working the resin in along the length of the cloth. I'm using a little bit more resin. It's hard to tell when you've saturated carbon fiber. You can't see it change translucency or anything like you could with the glass. So use a little bit extra because with the heat tape winding process, we're going to be actually coming back and bleeding off that excess resin out of the laminate. Carbon is real good when you start this brushing type motion in the middle of the layup, because it doesn't move on you at all. It sticks to the tube real well, it conforms to the surface, and you can really manhandle it a little bit to get that resin on without harming the carbon. Again, I'm working quickly with this stuff just to get all this information into the 2-hour video that we're doing. But you've got an hour working time per pot of resin that you mix. So take it easy, take it slow, and do it right. I talked briefly in the materials introduction about how expensive this stuff is. It's very expensive. Per running yard of material, expect to pay $25 and up for a 5 to 8 ounce carbon weave. Now this weave is a plain weave. The crow's foot weave is not as effective in carbon fiber because the material itself is so stiff. So plain weave is pretty much what you'll see in carbon. You'll also see something called a unidirectional weave, in which all the fibers are running in one direction, just like the name implies. And the fibers are all held together by little cross threads that go across those fiber directions and kind of just basically tack it together so you can work with it. Unidirectional cloth is very good to use when you need strength or stiffness in only one direction specifically. That has some applications in fins and things like that. But unidirectional cloth is very difficult to work with, especially in carbon. It can be actually kind of dangerous to work with because when you're cutting it, those fibers get airborne much easier. And I wouldn't recommend using unidirectional cloth for rocketry applications. It's just not the stuff that a home hobbyist wants to mess with. It also takes some very specific engineering of how the strength is going to run in your part, as far as how you orient the directions of those fibers. And remember, with composites, those fibers, whatever direction they're running in, no matter what the material is, that's the direction the strength's going to be in. So if you've got a cloth that's wound at 90 degrees, or that's woven at 90 degrees per course of material, you're going to get strength in 2 directions. There's also different kinds of cloths called triaxial cloths that are woven in 3 directions, actually, 3-dimensionally woven. Very strong cloth. But they're suited only for very specific applications, and they're usually woven especially for that application. You may see some of them in the vendor catalogs, but they're very thick cloths and not at all really what we're aiming for with a lightweight, strong structure. You can use them for occasional things, but just be aware they're an unusual material to work with. Okay, the carbon has gone on well, and we're nearing the end of the second wrap around the tube. Again, I've got about a ½ inch of overlap on either end of the tube to have somewhat of a runoff. So I'll get the whole tube looking real good. When I'm finished laminating and wrapping this tube, I've got a finished one that I'll show you. I'll also show you a finished plain wrap fiberglass tube that we did earlier. Now notice as I'm coming up again on the edge of the cloth, I'm doing the roll technique, just so I don't dislodge any of those carbon fibers. At this point in the laminate, if you do dislodge a fiber, don't worry about it. It's not going to affect the structure very much. What it will affect is the appearance, and carbon fibers are really cool looking material when it's done properly. So I like to keep it looking real nice. Now I've got the whole tube wrapped. Now I'm going to go back over the carbon and give it a gloss layer of resin. Now I'm only doing this to get a little extra resin in there so that when we start our heat tape winding, it's going to really compress those layers together. I'm sure a lot of you have heard about the process of vacuum bagging. We'll be doing vacuum bagging demonstrations in another video. It's quite involved, and it takes a lot of time to go through all the idiosyncrasies of vacuum bagging. But this heat tape winding process that I'm going to show you is a way to get that same kind of vacuum bag quality out of the composite laminate without the vacuum bag and without the vacuum pump and the $150 extra of material that you'd have to get to do the vacuum bagging process. So the key with this heat tape winding or with the vacuum bagging is to get those layers compacted together good and strong and bleed off the excess resin. And that's what creates a good structure. To that end, we sell a product, and it's a specially formulated heat tape. This tape does exactly what it sounds like it does. During the cure cycle of the resin will heat up, and this tape at that time heats up and it squeezes on the laminate, compacting those layers and bleeding off the excess resin where the tape layers overlap. Now the way to use this tape is just put a piece of tape on the end of it. Now you'll see the additional reason why I've got the runoff on these tubes. If we can zoom in here, I'm just starting this tape all the way at the end of the tube, past the carbon on the coupler at a shallow angle. I'm at about 15 degrees. And now I'm going to start wrapping this around. Let me do that again just to show you how we start the tape. Get your tape on the end there, nice shallow angle, and start wrapping it around. You'll come to the other side and you'll start to see your tape is overlapping. You want about an 1/8 inch of overlap from each course of tape as it winds around and overlaps itself. Now, I just apply gentle pressure to it and allow it to wrap gently around. I'm not pulling tight on the tape. I'm just allowing it to get that 1/8 of an inch of overlap here and pulling it around and trying to keep a consistent overlap. What that does is keeps the tape from wrinkling or buckling at the overlaps. If you do get wrinkling or buckling at the overlaps, it's okay. It's just going to make a small little dent in your composite laminate, and that's not going to affect the structure at all. It's just going to mean you're going to have to fill it before you paint it. But I'm having pretty good success here with no buckles at all. Just wrapping this tape around. Now you can see also, if we zoom in over here, resin is starting to drip out from between the layers of tape, just from the act of wrapping it. That's good. Again, I did add that excess resin so that all of these individual carbon fibers will be encapsulated and mingled with that resin in the laminate, which will give us our tremendous strength. So basically, that's heat tape winding. I'm just carefully taking it nice and easy, trying to maintain that consistent angle and overlap, and working my way down the tube. Now, after you get this tape onto the tube, what I want you to do is set it down and walk away from it and let it cure for the epoxy's complete cure cycle. Don't try and heat it up by putting it in an oven or anything. Just leave it alone. Go think about something other than rockets for about a day and a half, and then you'll get a good, strong cure. Well, we're cruising pretty well now with the tape, reaching about 2/3. Believe me, compared to vacuum bagging, this stuff goes on real quick. Vacuum bagging parts like this take a colossal amount of time in the setup and in the actual application of them to get a good result. So this is a real good way of just getting a really strong aerospace, true aerospace composite structure in a quick and easy and relatively clean way. You're spending a lot of money if you're reinforcing with carbon, and you really want to make sure that you've got a true aerospace technique that compacts those layers together and gets the maximum performance out of your materials if you're using this stuff. If you aren't, you're wasting your own time and money and just making a heavy rocket that's expensive. Okay, so now we've reached the end, and I'll just get a razor blade here and trim this off. Trim the tape, and then get some more masking tape. And tape down that end good and strong. As this stuff heats up and cures, it's going to pull on the ends of the tape and try to draw it in. So you want to come back on either end and just reinforce either end of where you started the heat tape with a couple wraps of masking tape just to hold it down in position real well. And that is all there is to heat tape winding. What I like to do now is just take a little sheet of wax paper, put it over the layup, and that's it. We'll take this off of the winding fixture and let it cure up. Now, let's show you a couple results of what that carbon fiber looks like when it's done. I've got one finished here that still has the heat tape on it. Now, if we can zoom in on that tube, what you'll see is that the heat tape has constricted around that tube. It's bled off any excess resin. There's no air bubbles under here. The excess resin is on the surface of the heat tape and it's all cured up. So let's take that off and see what it looks like. And we'll just show you how to remove it once the heat tape's done. Just removing my masking tape that holds on the ends. I did a good job here because it's tough to get off. And now we just remove the heat tape like this. And I'm just going to pull it and let it run right off the tube. And there we go. What I'm left with is a very, very strong carbon laminate. And we zoom in again to see what we've got. You'll end up with some spiral patterning where the tape overlapped itself. But if you look at that carbon laminate, there's no air bubbles. It's very, very smooth and very, very strong. 2 wraps around a standard tube, and I can't compress it at all. This is just a standard paper tube inside that would basically crush in my hands if I hadn't have reinforced it. So very, very strong, very, very light. That's carbon fiber. Here's an example of the just plain wrap of wrapping fiberglass onto a tube. I did this one on an 1¼ tube just to show that you can do it with smaller tubes. And this has 2 wraps around a paper tube, and I guess demonstrations proved more than anything, so a paper tube doesn't do that. So very, very strong again too. And that's just with standard glass. So. The next tube I'm going to do is for you guys that do smaller competition models. And this tube is going to be wrapped on a 10.5 millimeter tube. What I'm going to use for this purpose is a product that we sell also. It's called tissue. What it is it looks just like tissue. That's fiberglass, 0.3 ounce fiberglass. Very, very strong for its weight. We sell the same product in carbon fiber, 0.3 ounce carbon fiber. I've done one of these tubes in carbon fiber. I'm going to do one in glass, and we'll show you the results. They're very easy to do. It takes a lot of experimenting, just like any other process. When you get down to using this stuff, but you can get some very, very strong competition tubes for some of your contest models by using this stuff. What I've done here, and we need to zoom in as close as we can on this tube near my hand, is that I've taken some of the glass tissue and I've attached it to this 10.5 millimeter tube with a 1/8 inch strip of household Scotch tape. That's just to hold the edge right against this tube as we wrap it. With these smaller diameters, the materials don't like to go around the tube as easily, so that holds it onto the tube. I've also got little tube couplers out of either end to give myself a little bit of runoff and overlap so I get a full tube length. Now the way we work with this, I'm going to be working down on this wax paper that I've laid down in front of me. I set the tube with the glass fiber right down on the wax paper in front of me. Now I'm going to use some of the resin that I had mixed up for the last batch because it still hasn't kicked yet. And you do this differently. You don't apply this cloth the same, or the tissue. I've got it down on the wax paper, and now I'm going to wet out that the tissue on the wax paper until it goes clear. I'm not applying any epoxy to the tube itself. I'm just wetting out this material so it goes clear. Now, a lot of you guys that make these competition models are great craftsmen, and this is a good opportunity to show your craftsmanship because it's going to take you a lot of practice to get this right. But what you'll have as a result is a tube that's around 1/3 the weight of your existing paper tubes or other competition tubes, and probably 3 times stronger. So now I've got this nice and wet out It's basically all clear, or it will be in a minute as the epoxy soaks through. And it's stuck down to that wax paper. Because we took the time to come in beforehand and tape down that glass to the tube, now if we can get a close-up of this general area, you can see what I'm going to do. I'm going to roll this tube with the glass that's all impregnated with resin, and I'm applying somewhat of a back pressure to it as I wind it so that I get some tension in this and get that glass to wrap nicely. And now I have it. I lift it up and just lay down that edge with the brush. Now this may take some going at it, in that the resin needs to soak into the tissue a little bit and dissolve the little binder material that's holding those glass fibers together. It needs to dissolve it so it'll make that final kick around the corner and let that edge lay down. So it takes just a little time. So what I want you to do is just take this tube, and with that raw edge, I want you to just keep working it and using that same rolling technique that we used on the tubes and rolling it down. Okay? And as you keep doing that, that tag edge will lay down. The whole process is going to take you probably 20 minutes to get that to lay down, okay? So what I'm going to do is toss this and go on and show you what the results are so that we can get on to something else. If we can zoom in on this, now this is a tube made with the carbon tissue using that technique around a 10.5 millimeter tube. Beautiful tube. Let's weigh it just to see what it weighs. You know what competition tubes like this weigh. I'm putting it on there. 2.5 grams. So that's an exceptionally strong tube in a small size for your competition models. It takes a lot of practice to use this technique and get used to it. Luckily, the materials are a lot less expensive, and if you hang with it, you can get a really good result out of it. So now we're going to move on to our last project, which is the Kevlar wrapped tube. Now this tube is going to be the tube where we dissolve out the inside paper tube when it's finished. What you have then is the ultimate in performance for your materials used. So let's get to work again. I've got another tube prepped, ready to go. This tube is prepared the same as the other tubes, except I've taken and used a released agent on the tube. I sprayed this onto the tube. This is a dry release agent. You can use any kinds of dry or release agents like carnauba wax, but use one specifically called out by your vendor catalogs as used for epoxy release. If I was to use the wax on the tubes, I would apply wax to the tubes, let it dry, buff it off, and go through that cycle about 4 times. That gives you a good release off of this tube. This dry stuff is very toxic to use. I only spray it in a forced oxygen environment, so I wouldn't recommend some of these dry things. You probably can't get these anyways. Only professionals in the industry can get these. So I've used it on this tube just because it's a fast and easy way for me to do it. Any release will work for you. Tubes prepped the same with the friction fitted coupler ends on it, and covered by wax paper, and we will just mix up another batch of epoxy. I'm going to lay down another strip of wax paper here to keep everything clean. Like to keep a container of wax paper around when I'm doing a lot of laminates. Any drips that occur, anything like that, you just pull the stuff up when you're done and throw it away, and it's nice and clean and keeps everything looking good. So let's mix up some epoxy. I'm going through and mixing this stuff up a number of times to try and instill in your head how important it is to get a good system down for mixing this stuff. Of course, I've got the digital scale. That makes it much easier for me. But you can do the same thing by volume like I showed you. Okay, for this one, I'm going to mix up a tad more epoxy, 150 grams. I'm going to use more epoxy because Kevlar is even more extreme than carbon in that it does not like to soak up the resin, and you have to force it through the fibers in the Kevlar. So for this, we'll get the appropriate amount of hardener. And there we go. Mix it up. Now, Kevlar is a very interesting material. A lot of people don't work with it just because they can't cut it. If you get those special Kevlar cutting shears, again for under 20 bucks, it works great. It's very difficult to work with also in that it does not like to be sanded. It's very, very, very difficult to cut, so obviously your abrasives that are in your sandpaper are not going to cut it or cut into its surface. So here we've got our Kevlar cut to the proper size. Now I'm going to wet out the whole tube. Remember, this has release agent on it. It won't affect how you wet it out at all. Just brush it on and go. Again, get a good gloss on the tube. I hope you like our background here that we're working with. This is Big Bear Lake behind us. We live about a half hour away from the Lucerne Valley Test Range, so all the ideas you see here that we're putting out to you, it's not just based on nothing. This is We've made rockets with this stuff and launched it with this stuff a lot, and found out what works best. So now my tube's covered with resin, and again, here we go winding. This is an 8-ounce Kevlar product, and it's quite moldable and easy to work with. All you got to do is get all the resin in there. So again, get your rolling technique down all along the edge as you start it, and get that edge to stick down to the tube really well. We're going to be using the heat tape winding on this material to force those fibers together. And what you'll find is, in the course of your laminate practice, you may notice that that little first edge that you put down wants to stick up sometimes. When you do a dry wrap without any compaction afterwards, you run the risk of getting air bubbles in the laminate. To get really realistic about the applications in rocketry that you do a fiberglass wrap with, that may not bother you whatsoever. It bugs me because it's not using the material, to its optimum property. But you can get away with that. With the heat tape winding, what you get, it compacts that down, so all air bubbles are eliminated. Therefore, you get a good quality aerospace composite structure. Now, if we could just zoom in on this area right here, you can see Kevlar wet out. It does darken somewhat as you wet it out. This is not wet out, this is wet out. And so it becomes a little darker hue of gold as you wet it out. When in doubt with Kevlar, use more resin, especially if you're going to be compacting it later with the heat tape, because you'll be bleeding off any excess resin. I would not recommend using Kevlar for just plain laminate layups. Without the compaction, the Kevlar doesn't achieve the mechanical properties that it's meant to achieve. And all it'll be is basically a tough structure of layers of Kevlar separated by brittle layers of glass, or resin. That's, of course, very brittle, like we discussed earlier. So, if you're going to use Kevlar, use a compaction method. That's really the best way to use it. So, we're just working our way around the tube, wetting out the cloth. I've already overlapped the starting point, that little tag end, and you'll be able to see it as you go over the tag end if there's any bubbles or anything underneath it, no matter which of these materials that you work with. So try and keep the bubbles in your overlap down. Doesn't matter as much with our heat tape winding. We also sell the heat tape winding in a perforated version, and that tape has, just like it sounds, little perforations about every 1/8 of an inch that further help to bleed off more and more of that resin. So if that's your bag, go for that. The plain smooth tape, non-perforated, works well for most applications, and unless you have a real special lightweight larger project that you're going to do, you probably want to stick with the smoother tape, but we do sell the perforated stuff as well. The rockets that I had out on display earlier are the Raven kits that now have become kind of legendary, at least on the West Coast and in Europe with some of our customers over there. for their strength. One of my prototypes has over 40 flights on it. They're not a disposable paper rocket like you'll find with most of the companies out there. We really engineered that rocket as a total composite structure from start to finish, and it's really proven it in the performance of it. The prototype on a Cosden J950 motor has exceeded Mach 2. And I don't know of any other kit out there on the market today that could brag about that. So just working around the tube. Again, I'm coming to the end of my wrap again, so just using the rolling technique to make sure that last end is down there. I don't have to be hypercritical about it because the tape winding is going to happen after this, but I like to get all those resin, or get all the fibers near the ends saturated as well, so everything is soaking with resin. Notice it's not dripping with resin, it's just soaked with resin and saturated. Try to get that 50-50 resin to reinforcement ratio. Okay, now we've got that. Got a little bit of a wrinkle on the end of it, so I'm going to pull the ends of the cloth just to stretch it out a little bit and get that to lay down. You can do it with Kevlar. If I would have done that with glass, the glass would have unraveled, so Kevlar is tough stuff again. So now I've got the tube all laminated. Time for the heat tape. So give it a little piece of masking tape on the end. Start the shallow angle. Make sure that masking tape's fixed down well. And look, I'm wrapping in the same direction that the Kevlar went onto the tube. By doing this, I'm tightening down that Kevlar in its wrap. If you go against how the material is wrapped onto the tube, you're going to probably incur some wrinkles and bubbles on the inside of the laminate. So go in the same direction that you wrap the cloth on. Again, holding that same overlap, holding the angle, and wrapping it on with just a slight tension between your thumbs and the tube as it wraps on. Just take it nice and easy. If you get it on clean with no wrinkles, that's what you're going to end up with after it shrinks down. If there are any little buckles in the tape or anything, they'll just compact down and end up in the laminate surface. It won't affect it that much, again, and it'll just be something you'll have to fill a little later on. But just working our way down the tube. If you do get an exceptionally sloppy winding technique and you still want to try to let it cure, what you can do is take a hair dryer and very lightly and carefully you can start the tape to shrinking. So it'll start to get clean around the tube. Do it very carefully, please, because as you're heating this up, you're also going to be heating up the resin, and the resin will get very thin and run out of the laminate faster. So you got to kind of play it by ear. Don't use a heavy-duty heat gun that's going to produce too much heat. That will just make it a totally dry laminate on the inside. It'll run all the resin right on out of it. So now we're right up to the end here. Trim off the heat tape. And tape that down nice and snug on the ends of the tube again. And there we go. A Kevlar wound tube with the heat tape finish. We'll set this aside. And here I have an example of what the Kevlar tube comes out like. This is the heat tape Kevlar tube. The paper tube has been dissolved from the inside of the tube, so it's extremely light. And the thing about Kevlar is I've still got a little bit of resiliency to it. It's got, remember, tremendous impact resistance, and it's a little bit flexible, but that's okay. It's very light, and I've got just enough strength here for what I want to accomplish. It's longitudinally very stiff. And again, very, very strong. So, Kevlar tubes. What I'd like to show now are a couple examples of a true composite aerospace quality tubes. This is the same tube that goes into our Raven kit, and it's a 38mm tube basically. It takes 38mm motors. But it's a filament wound carbon tube, and you remember me talking about how the strength comes in whatever direction that fiber is running, right? This tube is wound around a tool, or a mandrel as it's called, which is polished stainless, just a big long cylinder of polished stainless in the right size. It's wound around that by a filament winding machine, it's called, that winds with an individual fiber yarn, essentially, or it's called tow, of carbon fiber around that in specific directions. This one, on the inside of the tube, it's wound at -10 degrees relative to its length. The second layer is longitudinal layer at 0 degrees, and then the third layer is at 10 degrees. That creates a very, very strong airframe. And that's one of the reasons for the success of our Raven kits, is that they use this airframe. It's unbreakable virtually, and you can use as large as ejection charge as you like in this stuff, and it just will not break. You could use this for a cannon or a mortar tube with no problem. That's the strength that it has. Another type, or a different brand of filament wound tube that you'll see here. If we could zoom in on the tube itself, you can see the texture of the windings inside. This is called triaxial winding, in which the individual fibers of carbon are actually woven together three-dimensionally to get the strength that you want. I came by these tubes from a friend down south, and I'll be using them for my level 3 project just to prove the superiority of these kind of materials. This rocket will be about 12 feet long and is all carbon fiber in its construction. So just a little something to drool over. It's fun stuff, very expensive, but this is real aerospace stuff. That just about wraps it up for this video, and as I said, we'll try and make more videos in this series on vacuum bagging, finishing, things like that if your interest warrants it. Thank you very much for watching all of this, and I hope through your practice that you can get down to making some really good stuff. I'd like to think that we're more than mere hobbyists, that we can get a little bit of rocket science involved in what we do, and hopefully this saves you some time and money in getting knowledgeable and proficient on this. Thanks.